These are the pre-calc notes 3.2. We're going to talk about scatter plots and what we call best fit lines today. So a best fit line is a line in the form y equals mx plus b, so slope-intercept form, that best represents the data on a scatter plot. It usually passes through 2 points, but it could pass through more. And best fit lines obviously are only going to work for linear scatter plots. So for example, part A, we're going to start by creating a scatter plot. This right here is your 0, 0. Just be mindful of that. And we're going to plot each of these points. 3, 0. 5, 2. And what might also be helpful, which I'll often do, is just kind of put little tick marks every 5 places. 1, 2, 3, 4, 5. And label. That's often helpful, especially if you have several dots. All right, and then we'll get to back to plotting. I've done the 3, 0, I've done the 5, 2, 7, 3, 9, 6, so over 9, up 6. 11, 9. And 15, 11. And again, notice it generally looks like a line, but it is not a perfect correlation. They're not exactly lined up. That's okay. Part B says draw a best fit line through the points 5, 2 and 9, 6. So 5, 2 was this one right here. And 9, 6, this one right here. Just go ahead and draw a line through those as best you can. That's done. And then we're actually going to find the slope of that line. So notice a few of the dots are below it, a couple of are above it, and this one actually here at the bottom actually goes through it. But it's just a very good line that kind of represents all of our points. In order to find the slope, we'll use our slope formula. y2 minus y1 over x2 minus x1. I'll label my points up here in part B, x1, y1, x2, and y2. Then we'll just plug them in. y2 is 6, minus y1 is 2. x2 is 9, minus x1 is 5. 6 minus 2 is 4. 9 minus 5 is 4. And I'll divide that out to get a slope of 1. And you can double check that on your graph. Starting from this pink dot here, you can go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and you can see that it is a slope of 1. Next thing we're going to do is write the equation of the best fit line. In order to do that, we're going to write it in point slope form, which is y minus y1 equals m times x minus x1. So we'll use our x1 and y1 from part B, and of course our slope that we found from part C1. Y minus 2 equals m, which is 1, x minus 5. We want to make sure we turn that into slope-intercept form, so I'll distribute. And then add 2 to both sides to get the y by itself. I'm going to go ahead and leave off the 1x and just write it as x minus 3. And there's my equation of the line. Part E, describe the correlation of the scatter plot. Is it positive, negative, or none? There's two ways you can do that. You can either look at the actual scatter plot and notice that the dots are tending upwards, or you can go to the slope. The slope will either be a positive or a negative, depending on what your points are doing. And this one's obviously a positive. Let's look at one more. This scatter plot has been done for you. But this is actually giving you some actual information. The data shown represents the age of a child in months. That's important. And their weight in pounds. Use the data to analyze the scatter plot. Scatter plot has been created for you. So they took all these ages and weights and they plotted them here using those blue dots. So keep in mind here, when you see this 24 months is that 2 years old. Okay, so keep that in mind. We're working in months here. All right, part A, draw the best fit line through the points 24, 25 and 34, 32. So you can see the scale across the bottom, 24, 25 would be that point right here. And 34, 32 would be that one right here. You're just going to draw that line through them as best you can. And again, you can see that some of the dots are below that line and some are above. The next thing we're going to do, find the slope of the line. And again, y2 minus y1 over x2 minus x1. If you do decide to count your slope on your graph, remember that these are counting by twos here. So each block would be a count of 2. So just be careful if you decide to do it that way. I'll subtract those, 7, and subtract the denominator to make 10. And I'm actually going to work with a decimal instead. So I'm just going to go ahead and divide 7 by 10 to get 0.7. Now I'm going to go right below it and look at part C. Interpret the slope. What that means is, what does 0.7 have to do with this problem? So here's how we're going to write that. We're going to talk about the months first. So for each month that passes by, the weight goes up by our slope, 0.7. So for each month, each 1 month that passes by, the child's weight increases by 0.7 pounds. Any sentence that sounds similar to that is going to be acceptable. So for each month that passes, the child's weight increases by 0.7 pounds. We'll go ahead and find the equation of that. Y minus y1 equals m times x minus x1. We have a decimal here for the slope, so we're probably going to end up with some decimals in our answer. That's fine. Y minus 25 equals 0.7. X minus 24. You'll need to distribute the 0.7. It's probably going to require a calculator. I'll get mine. When I typed that into a calculator, 0.7 times 24 got me 16.8. And I'll add 25 to both sides. right. So my equation is y equals 0.7x plus 8.2. And that 8.2 is my starting point. That's actually the average birth weight of a baby, that 8.2 pounds. And then each month they go up by 0.7. All right, down here at the bottom, we're going to predict the weight of a 30-month-old. So make sure you're in months. We are. And all we're going to do is take that 30 and plug it in for this x over here. So y equals 0.7 times 30 plus 8.2. Multiply and then add the 8.2 to get 29.2 pounds. And then with these, always ask yourself whether that answer is reasonable. So we are talking about children here. Is it possible that a 30-month-old, so someone somewhere between 2 and 3 years old, is 29 pounds? Now that seems reasonable to me. You'll notice when it starts to get weird, you'll notice that the numbers are not right. All right, next one, we're going to predict the weight of a 5-year-old. A 5-year-old. Notice we're in years now. We need to make sure we turn that into months. So I'm going to multiply that by 12 to turn it into months. And I'm end up with 60 months. And then I'll plug it in. All right, I'm getting 50.2 pounds. Can a 5-year-old weigh 50 pounds? I think so. It seems about right. All right, now we're going to do part G. We're going to predict the weight of Mrs. Shannon. Here we go. So you would need my age. I am currently 39 years young. We'll have to take that and multiply it by 12 to get my months. So I am 468 months old. Every year I do this problem. It's 1 year closer to that 40. That's all right. 468 months. So let's plug this in and predict my weight. Right, 0.7 times 468. Add that to 8.2. I'm getting an answer of 335.8 pounds. So according to this chart, I should weigh 335.8 pounds. We know that's probably not correct. So what happens here when you're dealing with scatter plots? Okay, this is an example of something called extrapolation. Extrapolation. Sorry, I couldn't fit it all in there. Extrapolation. We'll learn more about that a little bit later. But what happens is this graph is only talking about children. Children are supposed to keep gaining weight. But at some point in your life, you should not continue to gain 0.7 pounds every month. So whatever that time is, maybe 17, 18, 19, 20 years old, eventually your weight kind of evens out, and it's not going to still follow this direct line. Right? At some point, it kind of starts to do one of these, right? Kind of like evens out. So with data, you have to be careful because it only works for the certain thing that you're talking about. Here, we're only talking about children and their weight. So if we try to extrapolate that to adults, the answer is going to be off. Okay? It's not that we did any math wrong. The math is correct. But sometimes with extrapolation, you get some weird numbers that really doesn't work out. All right, nice job today. If you have questions, always let me know.